Welcome back to the Automation Podcast, the world's #1 industrial automation product and technology show, thanks to you, our audience of highly skilled automation professionals. Thank you for being a member of our audience, and thank you for tuning back in this week. Now, if you're new to the show, my name is Shawn from Insights in Automation, and every week I try to invite a new vendor or expert on the show to talk industrial automation products and technologies. And because 25% of our audience listens to the show, not watches it, but only listens to it, if there's any visuals, I'll try to call out any details for our listening audience. That said, this week, it's actually an interview. I have Steve Mustard back on to talk about current trends in industrial automation. And so without further ado, let's get right into the show. Hey, everybody, welcome back to the show. Shawn Tierney here from Insights in Automation with my special guest, Steve Mustard, former president of the ISA, and you know he's been on the show many times if you've caught some of our previous episodes. Today we're back. In our last episode, we talked about digital twins. This time we're back to talk about just trends in automation in general. We're going to talk about all kinds of different things, and Steve is just somebody who's been out there in so many different industries that he knows a lot about this, and he's on the leading edge of some of these technologies. So I wanted to get him back on and just like pick his brain on these topics. But before we do that, in case you haven't seen our previous episodes with Steve, I did want to ask him to introduce himself. Steve, welcome back to the show. And please, could you introduce yourself to our audience, maybe some new members who are watching for the first time?
Yes, thanks, Shawn. Thanks for having me back. Steve Mustard, I'm an independent automation consultant. I have 35 years plus experience in automation profession in different sectors, from defense through oil and gas, water, wastewater, food and pharma, and transportation, as well as IT. I was the ISA 2021 president, as you mentioned, and one of the things that I focus a lot on is industrial cybersecurity. But in addition to that, a lot of my project work, especially recently, has been in this digital transformation type technology that we've been talking about with digital twins, but also some of the other stuff we'll hopefully talk about today.
Yeah, you know what? I want to pick your brain. We just had the incoming president of ISA come on the Automation Podcast to talk about OT cybersecurity. And so why don't we just start? And you didn't know I was going to ask this question, but I saw your picture. So you were at this event in London. And so I just wanted to ask you just thoughts where we are today as far as cybersecurity for OT. But before we jump in, I want to thank theautomationschool.com for sponsoring this episode of the show. That's where you'll find all of my online courses on Allen Bradley and Siemens PLCs and HMIs. So if you know anybody who needs to get up to speed on those products, please mention theautomationschool.com to them. And now let's jump back into the show.
Well, my experience, I've been working in OT cybersecurity for about 20 so years now, pretty much since we started talking about it. And what I always tell people is that the first conversations I had about OT cybersecurity way back when, I'm still having some of the same conversations today. So on one side, it sounds depressing, but on the other side, I mean, we have made a lot of progress. So a lot of sectors especially have done a lot of work and things have improved, but we still have quite a long way to go. And one of the main challenges really with cybersecurity is people and culture. It's not really the technology that's the issue. It's more making sure people are aware, making sure they don't do stupid things. And especially in OT environments, there's many things that you can do to either make things more secure, or if you don't do them, make yourself less secure. So my favorite example is always make sure you turn the key in the PLC to run mode when you're not programming. Simplest control that you can have in place, so that's but one of the good things is that ISA's conference that we just had in London brought a lot of speakers together to talk about OT cybersecurity from all kinds of different angles. So from the standards angle, from the secure by design angle, but then also things like AI and cybersecurity, quantum computing and cybersecurity, and all kinds of other intersections, supply chain, maritime, all of those kind of things. So helping discuss the topic and bring all these experts together obviously is one of the things that ISA can do to contribute to this, I think, as well as produce the ISA IEC 62443 standard, which we've
Yeah.
talked about before.
Yeah.
So, yeah.
Yeah, and we cover this on the morning show on a regular basis, and it's, you don't even have to do anything wrong to get compromised. I mean, you could be at a coffee shop picking up a box of coffee for the office, and somebody could hack your phone because of some
Mhm.
vulnerability in that latest version of whatever operating system. So, they even had a point where you are just charging at the airport, and people are hacking your phones through the charging port. So, it's just, it's kind of like that. See something, say something like at the airport. Hey, did some strange person just leave a big package near some vulnerable spot? You know,
Right.
it's if you think you're something in the control system doesn't look right, say it
Right.
immediately. We have to work together collaboratively
Right.
to do this. And that was actually there was a session for journalism for journalists over at the Automation Fair where they were talking about this, and some of the experts on the panel were saying, you know what, that's one of the biggest things is you gotta get everybody to buy in, realize it's not about trying to get them in trouble. It's trying to get we all got to work
Mhm.
together because there's new vulnerabilities and it's kind of like we're all on the ship. If you see a hole, mention it, or else we're
Yeah.
all gonna sink. Type of
Right.
mentality.
Right. It's very much like safety, and
Yes.
in our facilities, we're used to having it drilled into us about if you see some unsafe behavior, report it, stop work, things like that. And I think we need to have the same kind of mentality with cybersecurity. In fact,
But before we get into that, I wanted to thank those of you who signed up in our new membership program, either on YouTube or at theautomationblog.com. In appreciation of your support, you get exclusive access to the videos of episodes that are not sponsored by the vendor. Now, to learn more about our membership program, which is only $10 a month, please visit theautomationblog.com/memberships. And with that, let's go ahead and jump back into this week's episode.
more than that, I actually, even though I spend a lot of time talking about cybersecurity, I actually try to avoid making cybersecurity a special thing on its own. To me, in our space where we work, cybersecurity is just a cause of a availability or a safety issue, right? So your loss of production, your loss of containment, your harm to people, those kind of things that can happen for various reasons. There's another reason, which is cybersecurity. And so I think if we think about it like that, because of our experience, because of our knowledge about how to have all these layers of protection in place to protect us and people and the environment from harm, then we can use the same concepts to reduce the likelihood or consequence of a cybersecurity incident as well.
Yeah, you just reminded me. We had Eric Cosman on from ISA back in the winter around the holidays, and he said it. And I know this is something you guys are probably used to hearing, but it really stuck with me when he said it during on that show. Is you can't consider yourself safe if you don't have security, if you're not secure, right?
Right,
How safe can you be if some random dude can hack into your network and put everything into 100% or 150% or whatever, right?
right,
No,
right,
no, no. If somebody
right,
changes your recipe, from being a safe formula to being an unsafe or unhealthy formula, you're
right.
not safe. And so that what you were just saying reminds me of that. And that brings me to the next topic I want to talk about, which is and one vendor's actually doing. I just talked to him yesterday. We'll hopefully have him on the show, but they're having a summer of IoT or IIoT, right? And this kind of goes with digitization, although, and I'll get your opinion on this too. But when I think of IoT, I'm thinking more of the devices and the sensors versus digitization, where it's kind of wiring everything up and getting all the information. But in any case, and I was saying it earlier in the week, I'm like, you know, do you know everything that's installed on your plant floor that has connectivity? Because guess what? If your production manager has a IoT thing that somebody gave him and he's plugging it in, well, that could be a new vulnerability that could take down your entire production line. So I wanted to ask you, like, it's like I don't know, it's like, I don't want to say it's a fad. I think it's a good trend in many ways, but it's also if you aren't it's like not wearing your seatbelt while you're driving. It's like if you just bought a new Jeep and took all the doors off and you're not wearing your seatbelt, you're kind of putting yourself at risk, right? So what are your thoughts about this about IIoT? Is this a fad? Do you think, and like, haven't we been doing this forever anyways? Let me,
Well, that's the first thing, yeah. People who have spent their careers like you and I have in this space look at these new solutions that come out and kind of laugh because it's like,
yeah,
well, this is something we've been doing forever. We just didn't call it IIoT.
yeah,
But there are some distinctions, of course. So yeah, and you've hit on some of the things. So I mean, the way I see IIoT is that the thing that is the things that are different with it compared with conventional sensing and actuator type technology is that one, the device is probably got some instrumentation and processing capability combined, as opposed to a separate instrument and then a PLC or RTU that's going to read the data, right? It's probably more intelligent than those kind of devices generally, and but it's probably specifically designed for a particular type of measurement, right? So whether a good example is vibration, right? So you want to measure vibration, and you've got vibration sensors wired in to various places where you need them. But then, what if you need to measure vibration in a balance of plant that you don't have sensors on, or what if you need to measure
yeah,
vibration in an area that you don't have wiring? And so IIoT, to me, allows you to realize that measurement that you couldn't practically do before for cost or wiring or other kind of limitations. And then the other thing which you hit at, which is the big one from a risk and availability and cybersecurity point of view, is the connectivity, right? So the big difference with IIoT devices compared with conventional instrumentation and control devices is that instead of being designed like the conventional devices to go into a DCS, ICSS, or SCADA system directly, they're designed typically to collect some data, maybe do some processing locally, and then also go to often the cloud for some kind of analytics. And so people decided that conventional control system architecture with all its different layers is
hmm
too complicated to get the data from this layer to this layer to this layer to this layer all the way to the cloud, or it's too expensive, or it's not practical for compatibility point of view. And so what if we had a device that we could just plug in? It may be battery powered and it has some kind of wireless capability and it sends data direct to processing in the cloud. Wouldn't that be fantastic? Well, sure, it would be. But then you've got to think about it. As you said, you've got to say, well, okay, well, what are we doing? Is it going to create some new um, sort of vulnerability exploitable connection that we didn't have before into our facility? How are we going to connect it into the rest of the facility if we are? Um, and some of the other things that I ask people when we talk about that is, well, where actually are you going to look at the data? Are
yeah,
you going to, this vibration is a good example, is like if I'm going to measure vibration, I probably want to see that in my control room in my facility. And if
hmm
I want to see it in my control room in my facility, why would I want to send it to the cloud and then have to bring it back from the cloud to the facility when I can bring it directly into my facility and then still send it back there? So lots of things to think about. But as you say, I think the seatbelt analogy is good because, like a lot of this new technology, the problem is that we're not limited anymore by technology, right? We can do almost anything we want to do. The technology allows us to do that. The question we have to ask now is, should we be doing it? Right? Rather than can
yeah,
we do it, right? Now, it used to be 20 years ago, it was like, we can't do this. And
yes,
so we had to find other ways to do it. Now we can do anything we want, but
yep,
now we have to be careful. And that's where I am most concerned now and for the future is um, shows like yours are important and ISA is important because we need to make sure we educate people about the fundamentals of these systems, these facilities, understand the risk, understand the operational requirements, and then you can use technology to make things better. But please don't come to my facility and implement fantastic new technology without understanding the all the implications, not just cybersecurity, but the operational implications and other things as well. So that's why this is really good to talk about this stuff and keep having these discussions so that we make people think about these things.
yeah. And just in discussing things, that's why conversation is so important and free speech is so important. Hey everyone, I just wanted to jump in here and pay some bills. Thank you, first of all, for listening to this episode. And while today's vendor wasn't able to sponsor this episode, I still wanted to invest the time to bring it to you because I think you're like me. You like to learn about new products and technologies. So, with all that said, I'd like to ask you to consider becoming a member for just $10 a month, either on YouTube or at theautomationblog.com, to help me offset the cost of producing these episodes each week. In exchange for your membership, you will receive member-only perks, including access to my daily news show and ad-free editions of every unsponsored episode of this show. With that said, thanks again for tuning in this week, and now we'll return you to this week's episode. Most of us don't have the ability to think everything through without ever talking to anybody.
Hmm.
Most of us, most human beings, work things out through through saying it and then hearing it and processing that and then hearing what other people's viewpoints are. We're all in a big stadium. It may look like an interception on my side, but you may have a better view, and it's definitely pass interference, right? So that is what the beauty of community, the beauty of talking with other
Yeah.
people, and that's what makes us better as people. And that's why free speech is so important. We got to be able to talk things through, and that's why communities are so important. But and I can see, right? So this guy has a big area. He just wants to remotely monitor the place. There's no control, so he puts all these wireless sensors out there. They all go to the cloud. He builds an easy dashboard. He's excited. Now he knows the tank levels, the pressures, the temperatures, and there's no control. He just needs to know this, right? And he's excited. So he goes tell somebody else who's in a facility who needs to have security because maybe they have a secret sauce recipe or something, who already has all that stuff wired into his control system. And so he duplicates that out of his excitement, and yet he just added a bunch of new vectors to attack his control system and put all these things in because he didn't have to maybe work with a cranky controls guy. But at the same token, maybe that wasn't the best solution. It's just like the same thing with data collection, right? So if you're monitoring traffic, or you're the National Geological Service, you're monitoring different things. Yeah, having all that in the internet where you can view it from anywhere is great. But if you have one facility, do you really need all your data in the cloud? Like there's like maybe you're a company, you have five different plants, but none of the five plants really rely on each other. So does plant B really need to have access to plant A's data? Why are you putting this in the cloud? Do you really need to view it at home? Don't you have a secure VPN? You better, right? Why are you
Right.
why are you, why are you putting in? So it's that practical. People get excited about new technology,
Yeah.
but what's like, and I may get some hate mail for this, but the new Apple VR headset. People are like, yes, great consumer VR. I'm like, no, this is an early bird, like living on the bleeding edge product. There's other products for 10%, 15% the price that have a catalog of hundreds, if not thousands and thousands. This product has like three, so being that early, bleeding edge is not always the best thing to do. You want to
Right.
talk to people who actually do what you do. But yeah, tell me your thoughts on that too. I mean, it seems like there's this rush. I guess we'll transfer into the cloud here. It seems like there's a rush to put everything in the cloud, but people aren't asking, do I really need it in the cloud?
No, you make a great point. With cloud and with all the other things, what you get from a lot of business leaders is pushing down, saying, "Why aren't we doing cloud? Why aren't we doing AI? Why aren't we doing
Yes.
IoT?" And actually, I mean, it's a fair challenge, I suppose, but at the same time, it's exactly what you've just been saying, which is sometimes that's not appropriate, and it's not necessary. Not only not appropriate, but not necessary. So, here's some examples, right? So, it's different example, but there's a famous water treatment facility in Florida that got attacked in 2021, right?
Yeah.
Prior to 2021, when they got, well, I say attacked, I'll come back to that in a moment. Uh, Prior to that, the vendor who put that system in place had a page on their website where they were touting the benefits of their operators being able to see the status of the facility anywhere they wanted, right? Which is exactly your point. But it's like, well, do you actually need to see it? Or is it just nice to have? And
Exactly.
then
Exactly.
if you need to see it, do you need to change anything, or do you just want to see something? And so that's obviously different as well, right? Can I change values, which in that case they could, or should it just be read only? And that's another thing to think about as well, right? And by the way, with that example, I mean, I think you probably know, but I mean, originally everybody thought it was a intentional attack and someone had compromised the system, and
Yes.
then it turns out now, with hindsight, it looks like somebody just made a mistake, right? But
Yep.
but that's interesting. We could go on a different tangent about that. But let's go back to the cloud thing. So there are genuine reasons why the cloud is useful for automation environments, right? Because going back to my vibration example,
Yeah.
analyzing vibration data is not a simple task, right? Because you got to do like Fourier transforms, and you got to do all kinds of selection of characteristics and identification and things, and there's a lot of processing involved in that. And if you want to put the capability on site to do that, that might be difficult to do, especially if it's in a remote environment where you've got limited space and you can't
Yeah.
put all that computer equipment there. So processing it in the cloud kind of makes sense. But as you said, in some examples where you're just saying, well, I'm just going to store my historic data in somewhere for future use, and I'm never going to actually process it, analyze it, or even share it with anyone else, then yeah, it doesn't make sense to do that, and it creates these extra vulnerabilities which you didn't already have. So thinking about why you're doing it is sounds obvious, but honestly, the number of times I look at these things and think, so why are you doing that exactly? Did you really think about it, or are you just doing it because you can? And sometimes it is doing it because you can. So yeah, I think that we didn't. I know we talk about cloud, but of course, one of the other things that another buzzword that's out there is edge computing. And
Yes.
I suppose edge computing comes about because there's an idea that, like, okay, if we're not going to do all the processing in the cloud, maybe we can do a lot of the processing at the edge, i.e., where the action's happening.
Mm-hmm.
And so in order to do that, you need different types of devices, more processing power, but devices that can probably operate in those harsher environments and such like. So edge computing is another thing, a bit like IIoT, I suppose, in a way. It's not new in the sense that it's still just processing data, but the idea of where you're doing this processing is maybe changing. And instead of doing a lot of if you think about the traditional model of like the local control, supervisory control, manufacturing, and then kind of enterprise level. And instead of maybe doing a lot of the business analysis at the enterprise level, maybe you're doing more of that processing at the lower levels. And obviously you get a better response rate, you get a more accurate, more reliable, and maybe more resilient approach if you do that. So again, there's some benefits there, but again, you're putting computing power on networks and you're doing things, and then you're creating new vulnerabilities that didn't exist because maybe they're Windows devices that you're putting on a network with non-Windows devices, and now you're making that network more vulnerable because it's got Windows devices on it. And so you have to think about all of those things as well. Now, going off on a slightly even more of a tangent to that, another thing that really bugs me at the moment is that we talk about this integration of IT and OT, and that's a common phrase that comes up, right? OT,
Yep.
IT integration, IT, OT integration, whatever you
Yeah.
want to call
Yeah.
it. And we all understand, I think, the primary drivers for that, like being
Yeah.
able to get data from OT environments into IT environments so you can improve business processes and make things more efficient. That's all clear. But what I actually see now is that there's a trend going on now, which is that infrastructure is so reliable these days that people don't understand why we have separate OT networks and IT networks. They don't understand why we have redundant devices, redundant networks. Even if you look at a DCS, for instance, you've got redundant Ethernet, for instance, and you've got all kinds of levels of redundancy going on. And because this stuff is so reliable now, you now have people coming around saying, well, why are we spending all that money duplicating all this equipment? And why are we having separate networks? Why can't we just commingle all these things and reduce the number of devices we have? We can save a lot of money that way. And
Hey guys, Shawn jumping back in here to let you know about one of the new services I'm offering from my new downtown office. In addition to custom in-person training and virtual training, I'm also now offering one-on-one mentoring. This is a service that grew out of my online courses at theautomationschool.com, driven by students who completed my courses, were competent in their jobs, but then they'd run into difficult or confusing applications, and they wanted to hire me to sit with them virtually and review their projects, review their code, and ask questions. And I got to tell you, it's gone really well with the students I've done this with, and so now I'm releasing it to the public. If you want to know more, please use the contact link at either theautomationschool.com or theautomationblog.com. Now, another service I'm offering is the result of vendors and users coming to me and saying, Shawn, you got all that equipment in your studio. Could you test this for me? Or could you set up my computer and make sure it communicates to all those devices? And so I'm also offering PC configuration and application testing right here in my downtown office. So if you're interested in that, you can use the same two contact links to get in touch with me. And with that, that's all I have right now. Let's return to this week's episode of the Automation Podcast.
make it more efficient, make it easier to maintain, make it easier to manage. We're going to make a central network monitoring facility and management facility so we can manage all of the switches and everything from one location with the same group of people. And everything's great until it isn't. And then when it isn't, everything goes wrong. And so, it's a classic case of the low likelihood but high consequence type incident that we understand. But how do you prove to people when it hasn't happened or when it doesn't happen that they're designing stuff so that, and they're using this new technology and they're putting this technology in place and it works today, but how do you convince them that it might not work in the future? And when it doesn't work, you have a very, very serious problem on hand.
Yeah, and that's it can be a fatal flaw. I always tell people, have you looked at who got hacked this week? Because these multi-billion-dollar companies are getting hacked every week. And do you really want that connected directly to your control system? Please, no. I mean, I regret going to some of these websites and creating a password and logging in, and Intuit was just hacked earlier this week, and it's just like no. Listen, there's a difference between, like, do you store your power tools in the same box with your children's toys? Just asking. Do you? Because that's what you're asking. The people in the front office, their computers, they're swappable. If somebody's computers go down, IT can roll out another one in 5 minutes. They'll be back to work, right? It's very unlikely they have anything of consequence on their hard drive, right? Because if they're sick, somebody else needs to work on it, right? Not so. As a matter of fact, I hate to say this, but in a lot of plants, they may not have the latest copy of their PLC code saved anywhere or backed up, and that's bad, but not. But yeah, no. So having that isolation between the two. I had a good friend and a colleague customer who was telling me about a recent incident where the front office got hacked and they didn't give in to the ransomware, but it did cost them millions of dollars. But because the OT was separate and they had their own separate backups and they were actually following, good backup practices, which I learned when I got service certified back in the 90s, they didn't lose anything. And so I'm not jumping down that rat hole, but I want to go back to Edge though for a minute. I am so confused because it seems like Edge is one of those words that doesn't mean the same to everybody. So I think and I want to get your opinion on this because I don't think there's a right answer, but when I see Edge device, I see like a microcomputer that can do some processing locally that maybe an electronic circuit like a photo eye or vision camera couldn't. So you have an edge device. It's typically, to me, it's a lower power PC, right? It's small. Most of the time it's going to be fanless. And it's like just to give you some, not the server level, it's a small unit of processing.
Right.
But I see people saying other things like they have edge. These are like it's a server. It's an edge. It's like no, servers are not edge
Yeah.
devices. 24
Yeah.
cores. It's like what? So what? I mean, how do you when somebody says edge device or edge computing? Are you thinking big, small, or is it variable? I always think small, but then somebody comes out with an edge device that's it's 10 grand and it's like has all these you know uh, AI processing power, and I'm like, what? What? You're doing that at the edge? Really?
Yeah.
You couldn't
Well,
put that in the closet, air conditioning
right.
closet, like 10 feet
Right.
away? I mean, what's
Right.
going on here? But go ahead.
Yeah.
What are your thoughts
Well,
on that?
I'm with you. I mean, my traditional view of edge computing would be the same as yours, which is that it's a unit of processing. It's got a specific function, and it's put there on the edge to do only that specific function, right? It's not a general purpose machine. It's not there to do a multitude of things. It's there to do a particular type of processing in that particular manufacturing line or oil and gas process or whatever it might be. But I think I think it is true to say that, like a lot of these things, there's a spectrum, right? And I think with the advent of things like AI, machine learning, for instance, um, you can see now that take that original unit of processing that you had to do a specific function, and now you start to ask, well, if I can do that at the edge, could I do even more at the edge?
Yeah.
Could I use some AI or some machine learning to do something right on the manufacturing line that I couldn't do at the moment? And so I can see that they become more like servers, but again, they would still be have to be ruggedized. They still have to be designed for those harsh environments with vibration, shock, humidity, temperature, fanless, all those kind of things that you would expect, because again, they're in that environment where you can't expect to have nice climate control and such like. So I don't know really if that's the future, to have more and more processing, or whether it's to have the same kind of mix of some processing at the edge and then a lot of intense processing somewhere else, whether it be on premise or in the cloud. I still feel like that last model is probably more scalable,
Mhm.
because I think it's hard to envisage that you're going to be able to just scale up by rolling out, computers in all kinds of different parts of your facility, compared with saying, well, I'll do some key things on the facility and then I'll do the intense stuff in the cloud, where I can easily expand and scale that, and it's cheaper, right? As you
Mhm.
said, those edge servers, they're like, I don't know, they're 3 or 4 or even more times the cost of a server, and
Yeah,
so
exactly.
it's not something you can really practically do, I don't think, at the moment, at least.
Yeah.
So maybe in the future.
Yeah, I guess the
So
one use case I've seen is like very intensive vision systems, high
right,
speed lines where it's really just you need lots of detail. And so,
yeah,
yeah, then you have what I would just call an industrial computer that's really
yeah,
beefy. So it can
right,
process it there right on the line really fast. So you got 100 pots go per second, and it's like doing some, magic, magical vision type of machine
right.
vision type of applications. But to me, it's always been like I always go back to the OSI Soft Pi, and I think Aviva owns them now. They bought them for billions, but they used to deploy your nodes, and there's other software that
Mm-hmm.
did that too. We had collectors in the old transaction
Mm-hmm.
manager, and and they filtered the data out. So you don't need that same if the pressure is 100 psi for 8 hours, we don't need that every second,
Right.
right? And it has the
Yeah,
way to
exactly.
filter that out so it doesn't end up in
Yeah,
the database and that's where the relational databases fall apart is with
right.
that time series data. Just and I've been there when somebody did a query and it took an hour for it to, just to show a straight line. It's like,
Yeah.
but
Yeah, no, I mean that's a good example though of the thing that I find is interesting is this new technology that comes along. People who don't understand necessarily some of the characteristics of control system environments kind of deploy it like a sledgehammer, to solve a problem, right? So, as an example, not too long ago, it was all the rage to have things like Hadoop databases, these kind of flat file databases where you just basically throw everything in,
uh,
and then you put on top of that ODBC or, SQL type layers where you can extract the data from. And because data, of course, storage is so cheap,
Yeah.
theoretically. You can
Yeah.
just store everything forever, right?
Yeah.
But I mean, I don't know. It just doesn't seem right to me to not think systematically about these things and, like you said, describe them like in a way where you say, well, this is our requirement here, this is our requirement here, and we're going to do this here, then we're going to summarize this data here, then we're going to do this, and okay, I mean that maybe it requires maintenance and you have to update it when you change things, but you understand it all, right? And back to something you said early on is like with these newer technologies and this relatively low cost entry to some technologies, we're having people just put stuff together easily and do stuff, but then ask them to explain it, how it works, and what software it uses and what hardware it uses, and they can't necessarily tell you for sure, right? So in security, back to security, if you talk about software bills of material and hardware bills of material, they're all the rage now because these vulnerabilities that you talked about exist in firmware, they exist in microprocessors, and then software that sits on top of all of that
Yeah.
hardware and software. And unless you know exactly what's in your product, how do you know where all your vulnerabilities are, right? And
Yeah.
so if you're just going to build these things, or not only even build these things, but just pay a company and say, we're going to store all of our data here in your Hadoop database, and then you don't know what software is running on there, you don't know who's got access to it.
Yeah.
That's not a great model for the future, I don't think, for them.
And you kind of bring, when as you're talking, I'm thinking that's why I'm such a big fan of zero trust. So I remember somebody it was a power plant engineer, and he was just beating with a dead horse. I think it was a NERC advisory about a Rockwell Ethernet card. He's like, can't believe they get this vulnerability. This is unacceptable. I need to call I don't know, the CEO and tell him that he needs to get his boys on this and whatever, whatever. So, I go back to the office and I'm reading it, and it turned out that if you pinged the really fast, if you ping the Ethernet module, you may not be able to load the Ethernet module's web page. Nothing else. Your IO still comes in at 10 milliseconds every scan. Control system still works. But yes, so I'm kind of thinking, I'm like, if you have somebody on your OT network who's pinging your Ethernet card 10,000 times a second, well,
Mhm.
first of all, we get a physical problem that somebody got in there, or we have a network security problem that they remotely got in. But if I can't think of a better vulnerability to have that, oh, the web page nobody ever
Right.
uses
Yeah.
can't be accessed, right? So it's
Yeah.
like you got to read these things too. It's not like somebody
Right.
says, well, did you know they installed a SQL? I forget what they call it now. The SQL database. They have the Enterprise Edition where you can actually go in and edit the databases. It's not like, when NERC comes or when CISA comes out and says, oh, by the way, your voting machines have the Enterprise Manager on it, so anybody can edit the voting data. And it's like people are like, what does that mean? It's like, what? Anybody can log into my voting machine into SQL Server and just boot into XP and edit the votes? That's serious. But not being able to get a web page that anybody uses, it's like, come on, guys, what's going on? And I still don't know why CISA or and I may be getting the acronym wrong, but why they put that under the SCADA section in our area with all the PLCs and HMIs. But whatever, it
Yeah.
was just an interesting aside. But
Yeah.
yeah, so very interesting stuff. And I do want to go before we get the AI. I do want to talk about a couple of buzzwords with you. And one is digital transformation, and what is digitization? And this is for me, this is kind of like Edge a little bit, where it's like, are you just talking about networking everything together? We've been doing this since '79 with Modbus and Data Highway. What is going on here? But I mean, when you hear those words, and I don't know if you're thinking that they're the same thing or different, but digitization and digital transformation, I see them used interoperability, but I also see them used separately to mean
Yeah.
different things. So I just want to pick your brain a little bit. So digitization, let's start with that one. What's your take
Yeah.
on that? Because everybody's using that word.
Well, I've actually got three words that I use, and they
Okay.
are separate, but they're
Okay.
related. So digitization is the
All right.
first one, digitalization is the second one, and then digital transformation is the third one.
Okay.
So digitization for me, what that means is you take your analog data or you take your paper records and you convert them into electronic format. So my usual example is you take your paper P&IDs or isometric drawings and you convert them in its simplest
I
form,
see. Yep.
just a PDF, right?
Yep.
Or searchable, so you can actually search for valves and
Yes.
things on your
Yep.
P&IDs, right? So it's a real simple step, but it's a big step, right? So you've gone from having to have books of stuff and search through them manually to now everything's electronic, so you can put it on a tablet, you can
Yep.
put it on a laptop, and you can carry it around with you, right? So it's an important first step, but it doesn't necessarily well, actually, sorry, yeah, it doesn't necessarily change much of what you do, but it does make things a lot easier. The second step, digitalization, is where you start to introduce technology to make things, the jobs you do, easier to do, but you don't change the job. So another usual example I use, like if you're doing uh, manual readings, right? So you're going around reading gauges, for
Yes.
instance.
Yes.
So not, you'd either write it down on a piece of paper, or you might record it in a spreadsheet, but you
Hmm.
then have to go and type those values into some other database somewhere, and it's a lot of extra work. So digitalization is, you now have an app that's on your tablet, and you go around and maybe you in its simplest form, you write it on the tablet, but it puts it into the database directly.
Yes. Yeah.
Or you could even, some cases you can take a picture and, it'll read the picture and it'll send the data, right? So you haven't changed the process. You're still sending a person around reading stuff, but you're doing it a lot more efficiently. And then digital transformation, what you do there, as far as I'm concerned, is you change this thing completely. So you don't send a person to do the readings anymore. You introduce new technology like IIoT to read the data
Hmm. Hmm.
and capture it directly, or you use a robot of some type, like a drone, for instance, or
Yeah.
a tracked robot with a camera on it, and you read the picture of the dial, and then it reads the value. It uses um, some kind of AI to read the image and work out what the value says, and then it sends the data back. So now you're not just introducing technology to digitize things, but you're actually changing how people do stuff now. One of the things we talked about on the other podcast was, inspection. So, instead of sending people out to manually look at stuff and see where corrosion is, you can capture imagery and then you can analyze it with machine learning. And then you're not even sending people out anymore to do inspections. You're doing it all electronically. So you've really
Hmm.
changed how you do things, right? So that's my take on those kind of terms.
Yeah, I remember when Rockwell, we used to give out books in the 90s, early 90s. I was sending box of books out to engineers all the time with all the manuals in them, and they would call up and we'd pull out page 58 in the PLC 5 manual, and I'd walk them through, and then Rockwell, in the interim between the internet and that time, they came out with the data disk, and there were 4 discs, and I kept mine because they have some really old manuals on it. But they had 4 discs, and I had every manual on everything, and it was like most of them were real PDFs. Like some of the old stuff was scanned in, but most of them supported searching. Wow. And had links from the page numbers to the right pages. And I was like, wow, this is the future. I am so glad I spent all that money on that CD-ROM because now I could and it was powerful. And then the hard drives got big enough. It's just like, yeah, keep, we'll just keep a billion, not a billion.
Right.
We'll just keep a
Yeah.
100,000 manuals on my hard drive at all times.
Right.
And I still do that. But, and then of course it all went online, and now it's just so easy
Right.
to search on all the major vendors have these literature libraries or PDF repositories online where
Mhm.
thankfully it is so easy to get the manuals now because we're almost always connected if we're in our office and we can
Yeah.
just grab the manuals. So that has been transformational, I think, for every
Right.
industry. As far as control system goes, we got rid of the old operator consoles and put in flat screen touch
Hmm.
screens, right?
Hmm.
And we got rid of the manual interaction between many lines, and now the control system talks to each other, right? Whether you have a DCS or multiple PLCs, you actually the systems talk to each other, and it knows if I'm going faster, you have to go faster, and all this, and it and all that's being shown up on the touchscreen. And that type of transformation has been going on for so long, and I love talking to people who did these back in the very early 80s. They networked these things together, and they would, the advantages they have. And of course, technology and computers get so much more reliable, in the 80s than they were in the 60s and 70s. And so I kind of felt like we've been on this road, but it's kind of
Mhm.
like AI in a way, and we'll get to that next, but it's like people are just discovering this. Like people are just discovering self machine learning. It's like we've had
Right,
self-teaching products forever,
right,
right? It's like when
right.
everybody, I feel like it's like when everybody discovered smartphones, right? Like I was using a phone as a PDA for years, and then one day everybody's like, "Hey, there's this thing called an iPhone, and it's a smartphone." And it's like, oh, really? You guys just found out you can browse the web on your phone? And so that's, I kind of feel some of this digitization, and
Yeah.
I'm not saying it's bad because it's making, dragging the dinosaurs maybe that are in the front office to kind of catch up with
Mhm,
technology. Sometimes it's
mhm.
bad because they start stampeding, and it's like, oh, slow down.
Right,
There's a reason we didn't wire all that stuff together. If there's a good
right,
reason for that. Ask the experts. But
right.
I think do you see any downside? I mean, we already talked about the whole IoT thing and the downsides of that. But what do you think of those three, the digital transformation? Where do you think we are? Do you think we're going in the right direction overall? Most places are navigating that, or do you think there's some minefields in there that people are getting, or sand traps that people are getting stuck in with their digital transformations?
There's two or three things, some good things, and I think there's some minefields there. So the good things, yeah, like you said, people have started to catch on with some of the stuff that's been going on for a long time, and they've started to realize that why do we keep doing this stupid thing all the time when we can use technology in some way to make it easier? So that's a good thing for sure. I think the flip side of that is that something we touched on a couple of times already is that technology can do anything you want, but you have to make sure you know what it is you're trying to do and apply the technology in the right way. And I do still see some cases where people try and implement technology and they spend a lot of time and money and it doesn't succeed. And oftentimes it's because especially the transformation piece is more than just technology. It's people and culture and things like that that you can't just change. You said dinosaurs earlier, and that's very true. There's some people who just won't change how they do things because even if the way they do it isn't great, and it often is proven to have problems, at least they understand those problems. So you're asking them to embark on a thing where they don't know what problems they're going to have, and it's hard for them to trust, which I can understand. So that's a bit of a challenge. But then, of course, the thing I mentioned a moment ago is my biggest concern, which is the security thing. So like people
Yeah.
implementing things without really understanding the consequences of what they're doing and creating these new vulnerabilities that didn't exist before and for not necessarily any additional benefit either. So that's really the biggest concern. So I know you're going to talk about AI, but as an example of that, one of the challenges with generative AI, where you're taking vast amounts of content and then you're producing new content from, one of the challenges with that is that vast amount of content can have intellectual property in it. And if
Yes.
you're not careful, then you can inadvertently expose that intellectual property to people who shouldn't have access to it. And so, you mentioned about vendors and their manuals and things, and a lot of those vendors you talk about, you can only access those manuals if you're a customer, you've
Hmm.
got website access and, you can only have certain privileged access. But if you suddenly then make that available to everybody through a generative AI program like ChatGPT, then or Copilot, now potentially everybody's got access to it. So again, that's the kind of thing you need to think about before you kind of embark on these projects. So
Yeah, and I think that's a good segue into AI, and we discussed this quite a bit. I discussed this quite a bit with the audience. The issues with IP and copyrights is something that, they in their excitement to train their AI large language models, they violated a lot of laws and people's IP and copyrights. And it only became apparent when people started using their product.
Yeah.
And it's gotten so bad, and we can talk about hallucinations, but it's gotten so bad where lawyers have been censured for producing case studies or case case
Case law.
files,
Yeah.
case law that doesn't really exist. They ask the AI to give them some case law to back up what they're trying to propose, or the argument they're trying to make, and then they get found out that the case law doesn't exist, that the AI created it, like it was generative AI. Instead of making a picture or a song, it made up a case. And
Right. Right.
that's it. All joking aside, that is extremely dangerous because people could be thrown behind bars if that's not
Mm-hmm.
found out for no reason at all. But I think it's kind of funny because I said this to the audience. I'm like, if you want to get a project approved today, just put AI in it.
Yeah. Right. Right.
Say we're going to utilize the latest AI to increase production. Now, I'm not saying be dishonest, right? But you know how hard it is to get some of these projects
Yeah.
approved. So
Absolutely.
you got to find the AI piece in there, and now boom, it'll get approved right away. But I think in reality, though, a lot of people talk about, look, you gotta do your due diligence. Don't do a project that's not going to be beneficial for your company just to do it. And I've seen a lot of people do that, and it's sad when they get kind of roped into doing that. But long story short, when we talk AI, there's all different types, and I know Siemens and Schneider and Rockwell, they're all working, and others. A lot of them are working with Microsoft or other providers to do co-pilots where they mine their own products. We actually have an expert from one of those companies coming on the show here in a couple of weeks to talk about. I mean, you think of these vendors, they have a mountain of IP, and they have had a hard time getting the right paragraphs of the right manuals or the right sample code to their customers. And if they can use the power of something like the Copilot AI to go through their vast volumes of hands-on labs and sample code and man, could they make, I mean, just think as a it's kind of like when you get that DVD full of PDFs. Imagine how much more efficient these people are going to be used. It's like,
Mm-hmm.
oh, I can never remember the control logic path when I want to do a manual path out a chassis through another chassis to another chassis. What is that? Is it IP address, backplane, channel, node address? It's like you
Mm-hmm.
just ask the AI instead of you trying to remember what book that was in.
Right.
But it comes, hopefully, it comes up, and it's like, what a time saver, right? There's like the
Right.
a database search engine on steroids,
Right.
right? And so I
Right.
definitely see that part. And that I think that's distinct, and I'll ask your opinion on this, from machine learning. We already talked about
Mm.
self-teaching cameras and all that. And we've talked about, reviewing images, and that also for predictive maintenance and condition monitoring is huge, like you were saying, right? It's kind of like the Alexa model,
Mm-hmm.
the naturally dragging speaking software that used to run on my PC and used to try to understand my funky accent, never did a good job. And that's what they realized. All these companies, Google and Amazon, they all realized we need a server in the cloud that's just a bazillion times more powerful than your PC. And that's why Alexa and Siri don't work when they're not connected to the internet. But the advantages there, those same advantages exist in predictive maintenance, condition monitoring, teaching your camera how to, identify different problems in your system, like we talked about earlier. But let me get your take as far as in industry, right? So manufacturing, utilities, and whatnot. Where do you see? We got generative AI, we got machine learning. Where do you see that? What do you see our current state is, and where do you see it going?
Well, I think we talked earlier about AI is another one of those things that's been around for a long time. So
Yeah,
in automation systems, so we've had expert systems, we've had neural networks, we've had fuzzy logic,
yeah,
we've had all kinds of different types of AI that have been deployed in control systems over many years to
yep.
improve control algorithms, make them more resilient and better able to handle kind of the spurious nature of processes. Um, so now, so the machine learning and generative AI in particular, those two things. There's cognitive AI as well, which I think is is a step too far at the moment for what we're talking about because we're going into trying to recreate how people think. But yeah, if you take generative AI, I mean, the use case that you gave there with the kind of helping people program things is great. Other examples I see are things like helping produce specifications from requirements that companies have in all of their different specification documents. Also compliance checking, so going through specifications and verifying that they meet companies' requirements, all that kind of stuff. I think those are actually beneficial, and they have the benefit that they inform humans and then allow humans to make the final decision. And so you still have that human in the loop that makes sure that, yeah, you're not going to do some crazy thing that you didn't check. The ones that I'm concerned about going forward, for the same reasons you mentioned, things like hallucinations, is, hey, wouldn't it be great to automatically generate PLC code for something based on some requirements? And I'm thinking, well, sure, but the amount of validation and checking you're going to need to do on that, I'm not sure the benefit is there, certainly at the moment, So I would not want to trust something that was written by a computer. So I would want to do extensive testing. But testing PLC programs, for instance, using AI,
Mm,
identifying test cases that can test the boundaries of PLC programs, I think would be a great example because
yeah,
that's the kind of thing that humans are just not very good at, right? We're intuitively bad at
tedious.
saying,
Yeah.
let's see how I can break this. You never do that. You
Mm.
go, oh, look, it works. And then you go deliver. But
And then
yeah,
it fails the first operator test. It's like,
right, right,
why did you do that again? Because that's what
right,
I always
right.
do.
Yeah. So I think there's some great opportunities for
Yeah.
generative AI for sure. For machine learning, we touched on things like corrosion, your vision systems, things like that. Anything that involves looking at something and identifying differences, um, I think it's great at. And one of the reasons why I think we have only recently been able to get these massive benefits in the last, few years, is because of the processing power again, right? So,
Yeah.
um, it's always been possible to analyze thousands and thousands and thousands of images and try to identify good and bad, and then, have an operator kind of confirm when the machine learning tells them something and gradually help it learn. But I mean, I think now it's better. It's just better. You can do that much more rapidly now, and you can do it in real time as well. So I think that I think actually that kind of thing, we talked about it when we talked about corrosion inspection. You A great inspector, yeah, might be able to see something that a program can't because of their vast experience that hasn't been learned in machine learning. But actually, I look at it the other way, which is I could give the same information to the same machine learning algorithm, and it'll always give me the consistent result. Whereas if I
Yeah.
give that information to five different people, I could
Mhm.
get five different results, right? And so it's very
Absolutely.
much dependent on the quality of the person. And so this is not dependent on the quality of the person, it's dependent on the quality of the data that you provide it with. And so that can only get better over time with machine learning because you're constantly feeding it new information. Your examples of Tesla, where they discover a scenario they've never seen before. That's a new scenario that gets learned, and then the next time that scenario happens,
Yep.
you don't have the same result, and over time it just gets better and better and better. So I think machine learning has a lot of potential for the future as well for that reason. But again, it's all down to um, the same story that we've said for all of this technology, which is you've got to use it with care.
Mm.
You got to apply it in the right circumstances where it makes sense, and you've got to just be very cautious about some of the other issues. For instance, with AI, you now depending on where this thing exists in your network, you've now got new vulnerabilities that didn't exist before. You've got new software that exists that has vulnerabilities. You've got new devices that exist that have vulnerabilities. And so you're introducing stuff into your environment that didn't exist before, and you're changing the security posture of your environment just by introducing that new technology.
Yeah, yeah. I think about the predictive maintenance and the condition monitoring folks, and they have the right idea. So they've been doing this forever, right? They kind of have to. They need advanced algorithms to see into the future. But the thing is, if they say the bearings are going bad on that motor, right? Better safe than sorry. You're better
Right,
safe than the retrofitted.
right,
You plan the maintenance than to have it break, and you may find out that's not as bad as you thought. But that's
right.
better than having it
Yeah,
run to failure,
right.
because you're leaving not it's not the you're not scheduling the maintenance. You're scheduling.
Mhm.
You're saying it's fine versus it's bad. So it's like writing your PLC program. I wouldn't want it to do that. However, if our engineers have already created some blocks that are
Mhm.
pristine and have been used, well, I would say, hey, look, I got 3 loops here. Go ahead and insert our library of blocks
Mhm.
that humans have tested and proven. And,
Mhm.
and, and that's the type of, it's a step above copy and paste. It's the generative, generating it from already seasoned and
Mhm.
certified blocks, which I think that can be great. It's like, hey, I want the same system as last week, but we're going to take out 2 thermocouples. We're going to add in 3 conveyors, and give me that code. That's where I think we can save a lot of time, because
Yeah.
I think it comes back to tediism. So, like you said, like checking the system, making sure there's no vulnerabilities or no unintended consequences in the program. That's the type of thing that people are like, oh,
Right.
all right. So what if they hit this button and this button, or
Yeah.
this button and this button, this button, this button? It's like we don't
Yeah.
like as humans
Right.
like to do
Yeah.
that, and that's why we tied that ox up to the grain mill and said,
Yeah.
"Here's a carrot in front of your
Right.
nose. Walk around all day. I got better things to do." Right?
Right. Right. Now, here's another great example of an
Okay.
application of AI that I think can really help. And this is back to the beginning of this discussion. We talked about the OT cybersecurity conference,
Yeah.
and
Yeah.
one of the pictures you might have seen was this cybersecurity escape room that we
It looks
demonstrated
so
there.
cool.
And it's a bit like the story you said about if you do a project, include AI and people will like it. So
Yeah.
this device, this environment had VR and it had AI. So everybody, of course, just goes, "This is great, a VR AI thing. I don't care what it is, it's great." But no, actually, it was really good because what we had is a generative AI based scenario generation, and you can basically say to it, I'm an oil and gas company. I've got 500 employees and I've got this facility, and I want to simulate a ransomware on one of the control system computers, right? And that you basically tell it that, and then it goes away and it comes back and it says, "This is what's happening. What do you want to do?" And then you basically asked to respond to a series of prompts, and then it's up to you to respond accordingly.
Yeah.
And the how you respond is analyzed at the end using the AI to say, you did either really well or really badly. This is what you did well. This is what you did badly. This is your score. This is how much the incident cost. And
Mm.
all of that's done based on, collection of information that's been aggregated over time about incidents and things so that you can, um, again, have a repeatable situation. So we had one person who had been working with this for a few weeks and not a cybersecurity expert, but they started and their score was like 40 out of 100, and their cost was like $2 million.
Oh.
And they just repeated the same thing over and over again and learned from how they responded and what they did well and what they did badly. And after a few weeks, they got to 85 out of 100 and only $45,000 in costs instead, right?
Much better.
So this is a person who doesn't know cybersecurity,
Yeah.
but has learned just from AI how better to respond. And the VR bit, which I should say as well, is part of the reason for the VR bit is not just because it's cool, but actually what I found from doing these kind of um, red team exercises or desktop exercises is that
Hmm.
you can do them in a tabletop environment where you sit around the table and say, "Let's pretend this happened. What would you do?" And then you kind of talk about it. But if you do it for real in a real environment, then it makes people respond completely differently, and it helps them learn differently as well,
Yeah.
right? So they get a different experience. So just by putting the goggles on and interacting with the AI in a simulated control room, they suddenly start to feel like, yeah, I'm really here, and now I can see the ransomware on the screen. And now, when I screw up step number two, and now I've got ransomware on full screens instead of, stopping it. Now I'm starting to panic, because I can see it's real, So it really does help educate people much better for that. So again, that's an example where the technology's there, but can you use it for something that's actually helpful, practical, and doesn't create all these other vulnerabilities and problems that we talked about earlier, right? So we're not going to change how we do certain things. We're not going to impact the process. We're not going to impact the operation. We're doing it all in a simulated environment, but we're learning and we're improving over time as we do it.
Yeah, it's very important because I think in most manufacturing facilities, anyways, the solution to a major problem is the e-stop. Products falling
Right,
off the conveyor, e-stop.
right,
Temperature's too
right,
high, e-stop, right? I mean, and for the most part, that's the right thing to do because it's a
right.
major malfunction, and we need to get somebody probably to help the operator figure out what's going on, a supervisor or an engineer or something. But when it comes to ransomware, you don't want to do that. It reminds me of my first virus. The international paper called up. They're like, our computer's not working. Can we borrow your program? And we send them a program that says, they call up, hey, your program's not working. We're sending it back to you. You got any more? We send them another one. They're like, this one doesn't work too. Like, I use these things daily. I'm like, there's something fishy going on here. And so we went out, bought an antivirus, and found out that they infected all our computers. So we did the exact wrong thing. We kept
Right.
sticking the floppy from the infected computer into the unaffected computer. And it's very similar with cybersecurity. Like you said, instead of just having one system compromised, now you have multiple. And so this is not the normal day in, day out way we do things in the manufacturing or
Mhm.
utilities. And so I
Right.
think I think that kind of training and the ICS for ICS thing you get the ISA's working on, I think all of that is so needed because it's not a natural walk and
Yeah,
talk, in
that's right.
the automation industrial world. So I really agree with you on that. That is so cool. And so I know I took a lot of your time today. Was there anything else? I think we covered everything on my list. I just wanted to throw it back to you to see if there's anything else you wanted to add to our conversation today.
No, I think this has been really, really good. I think, like I said early on, helping, talking about these things, talking about what they are, talking about what they can do, what they can't do, I think is really helpful. I mean, we may not be right. If we talk to two different people, they might have completely different opinions about these things, but all those opinions can be valid. And I think sharing this knowledge is really important. So I really enjoyed talking to you today about them.
Yeah, and I want to tell the audience, please, let us know your thoughts. Comment wherever you find this show, comment on it, or you can contact me directly. Because you know what? Hey, I just sit in an office now and teach courses and follow the news. You guys are still out there in the field, doing the job. So please, I love your insight. And with that, Steve, how do people, if people want to get in touch with you, maybe they wanted you to do some consulting or they want to read some of your books, how do people find you?
Well, I'm on LinkedIn. I'm also active volunteer with ISA. So if you're a member of ISA, we can connect that way. I'll be at ISA's automation event in October in Charleston, South Carolina. So that's the next big opportunity we'll have to kind of talk about digital transformation and cybersecurity. So, but yeah, I mean, I'm very happy to talk to people more and help people navigate their way through these kind of digital transformation things. For sure.
Awesome. Yeah, I think it's isa.org/events, if I remember
Right.
from the podcast we just did. So and it's in beautiful Charleston. So if you're a member of ISA, you want to go to that. That's automation all the time. Should be a good time. I can't go, but I wish I could. Well,
Yeah.
Steve,
Well,
thank
one
God.
one day we'll see you there. One day we'll see you at one of those events for sure.
Yeah, maybe 2025. That is, I forget. I think it's in Florida or somewhere else. But
Florida. Yeah, that's right.
yeah,
Yeah.
yeah. So the
Bring the
schedule
kids.
should
Bring the
align.
grandkids.
Yeah, bring the grandkids. Yeah, got them. Yeah. So in any case, Steve, thanks again for joining the conversation. I really appreciate you coming on and talking about all things automation.
All right. Thank you, Sean. Appreciate it. Great to talk to you. See you again soon. Thank you.
Well, I hope you enjoyed that episode, and I want to thank Steve for coming back on the show to share his perspective on the current trends in industrial automation. And I want to thank you for tuning back in, especially if you've joined the membership program. Members got this week's video as an exclusive because, of course, this is an interview. It wasn't sponsored by a vendor. So I want to say thank you to all my members. You guys make it possible for me to keep bringing this show out every week. I also want to thank all my students over at theautomationschool.com where I teach PLC, HMI, and SCADA products. I teach online. I also do virtual training. I also do in-person training. You may be wondering, Shawn, why is this week's episode a little late? Well, the students just left the office, so I'm recording the bumpers and trying to get it out as quickly as possible. But in any case, whether you're a member, whether you're a student, or whether you're just a listener, I appreciate all of you. I want to wish you all good health and happiness. And until next time, my friends, peace.